So throughout my career, I have worked with two different groups of people: coders that revel in code. I literally dream in code. I love it. But I also have to work with even more people who don't have the time or inclination to become good coders. And so I've been trying to figure out how we can get these two groups of people to work together the best. So let's just briefly go over the different user interfaces for data science. Of course, there's command line. I suspect probably everyone in this audience knows that. It's the most powerful, flexible, and extensible. It's easy to reuse your code, reproduce what you've done, but it's the hardest to learn, and you have to use it frequently. So many of the medical researchers that I work with, they only get a couple of data sets a year. They understand the analysis that they want to do, but they just don't do it frequently enough to get good with code. And publication. If you're trying to prepare your output for a journal or a report for the boss or whatever, then of course that's more code. And there's just like a whole set of things to learn about how to crank out nice looking HTML tables or LaTeX tables and so on. Now, kind of at the opposite end of the spectrum are software that is driven by menus and dialogs. SPSS, JMP, Minitab, Statistica, the list goes on and on. These things are so easy to learn because we forget that we learned as kids, well, my kids learned as kids anyway, how the menus work. And so you learn a word processor, you learn a spreadsheet. And so obviously at that point, you're learning how these menus and dialogs work. So you could literally sit down with any one of these kinds of programs, give it to your high school freshman and say, read this data set and give me a bar plot. And they would have no problem figuring that out quickly. Give them an R manual and the same instructions, you'd be coming back a day later with luck. Publication quality output pretty much is automatic these days. The output usually is in journal style tables, or you can get them easily in journal style tables. And it's automatically formatted as you go with whatever font you've chosen. Unfortunately, they're the least powerful, least flexible. Pretty much what's in the menus is what you get. If you want something different, then probably it's not going to do it, or it won't be easy to get it to do it. And if there is a workflow that's reproducible, probably it's done in code that the user doesn't understand. So many times I've had somebody who is, say, an SPSS user in my office, and they complain, I did 3 hours worth of work yesterday. Then today I found out I have an error in my data set. And now I'm going to have to sit down and do that 3 hours again. I'll say, no. There's this journal article, a journal a file that has stored everything you've done automatically. All you have to do is learn to open that and look through the code and just change a couple of lines where the data sets are read in. And they act, it's like with horror. No. I took a couple of programming classes. I'm not going there. I'll just do the 3 hours again, which makes me want to pull my hair out. So sort of halfway in between these two are these relatively new two-dimensional workflow diagram drawing tools. So NIME Rapid Miner, SAS Enterprise Miner, SPSS Modeler, and so on. You draw this two-dimensional workflow, and the workflow is itself the code, the instructions that tell the analysis what to do. So typically, the first thing you do is have an icon that says read a file, and then maybe you have 3 arrows going off in 3 different directions, what you're going to do with this file. So it looks really easy when you start. First time I saw one, I thought, well, this is as easy as the menus and dialogues approach. But as I got more deeply into it, I realized that it had all kinds of catches. So it is a powerful combination of diagrams and nodes, and you can drag a Python node into your diagram. You can drag an R node, a Hadoop node, and open that node up and put your code in there. and control those things. So that's nice. But overall, it's a workflow. There is no language behind the scenes. So this is easier than code, but it's harder to learn the menus and dialogs because you have to learn which directions, how to connect these icons together. Some icons can be connected, some of them can't. You have to learn those kinds of things. If you need to create a report or a journal article, then you have to hook up more nodes. You have to figure out which of all these nodes do you want in your report and hook up reporting nodes to those. So it's more complicated than they look up front. So I decided a couple of years ago I was going to try and study all the graphical user interfaces that were coming up for R and see if I could find a solution that would finally help me work with point and click people and still make our whole team of data scientists at the University of Tennessee happy. So these are the list here, and each one has pluses and minuses. So what I did was I chose one. I think I started with R Commander, and I wrote a review, and it might have been maybe 8 pages or something like that. And then I reviewed the next one and realized it did things R Commander didn't do, and vice versa. So my template review just got more and more complex until basically when I was done, each one of these things, except for this new one, R and Stat, which is fairly new. I haven't reviewed that yet. But these others, each one have a standardized 20-page, roughly 20-page review on each one of them, all done in the same order. So, step 1, how hard is it to install? Some of these things are pretty complicated to install. If you're an instructor handing this out to a class, you really want to know that, because otherwise your students are going to be driving you crazy. A lot of them are just a simple double click on an executable and it will install for you. So when I was done, I thought, all right, how can I summarize all this? I mean, 20 pages each, who's got time to read all of that? So what I did was the simplest possible thing, which was simply count the number of features that each one of these tools had. And so on this axis, you can see this is the number of analytic features. And so that is all of the statistics, machine learning, artificial intelligence kinds of things that the software can do. And on this axis is usability. So this is more complicated definition. And it includes, for example, how many data set types can I read? So I have to work with a lot of different researchers at a lot of different companies. They send me their data sets. I don't want to have to go figure out what tool is going to open that data set. I want whatever tool I'm using to be able to open all the different kinds of data sets if I can. Now, once the data set's open, oftentimes I see the data set's not in the form I need it to be. So all those kinds of usability things are all combined into this axis. And if you go to this website, you'll see I define these things carefully and I have a spreadsheet. So even though I weighted each feature with equally, you could apply whatever weighting method you wanted and come up with your own score to determine which one of these things would be the best for you. So we can see BlueSky is way the heck up here, a lot of analytic features, a lot of usability. If we replace this axis with visualization, then we got here just number of graphics features. And now Rattle went from being way down here to up to the number 2 position, but still BlueSky is hanging in there pretty well. So what the heck is this BlueSky thing? So it's free and open source software, and let's dive right in. So this is what BlueSky looks like. And this is, by the way, version 10. It's a beta test copy, so bear with me if it freezes and I have to restart it. But it's been pretty solid. So you can go to BlueSkyStatistics.com. You can download this. Make sure you go to the beta, not the regular download. Get the beta copy. And when you start it up, you'll see that there is a data editor here, and there is an output window here. Oh, let me clear that out. And hidden down in the corner here that a lot of users don't even end up looking at is an R editor. So let's look at these one by one. First of all, the data editor has little icons on it that tell you, so these 3 equal bars tell it that these are factors, species and island, in this penguin's data. And 1, 2, 3 means this is a numeric variable. If I switch to this housing data set, you'll see that the bars are now in order, saying that satisfaction, low, medium, and high, those values have order to them. All right, at the bottom of the window, you see you can choose to look at the data or information about the variables. So in the variable column here, or the name column, I can change the names of these variables. I can see what class they are. If it turned out that, say, something that happens frequently is something like island name comes in with a bunch of misspellings. So maybe it's read as a factor, but perhaps I need to make that a character variable so that I can go and standardize all those spellings and then come back later and make it a factor when all the spellings are standardized. Okay, so back to the data view. So then across the top, we've got a row of menu choices. And as usual, this triple bar menu, otherwise known as the Hamburger Menu, it deals with opening and closing files. And at the far other end, the triple dot menu has to do with changing settings of output tables. What style of table do you like? What theme in your graphs do you like? Under help, you can ask about getting started, and it'll take you to a bunch of videos on how to do these various things. All right, so let's then look at these, at the main menu headings one by one. The data sets menu has to do with things that are going to affect the entire data set. So if I was going to collapse the data set into sums or means, and now I have a new data set of these collapsed values I could work with. If I wanted to group by, we'll look at an example of this where I want to repeat anything I'm doing in here by the levels of some factor. If I want to merge data sets, do I want to join them or do I want to stack them up? If I need to reshape data sets, I can make it wider or make it longer. If I'm doing sampling, I might want to do a simple subset sample. I might want to do random or stratified splits into training and test data sets. And if I'm predicting a rare category, I might want to do either an upsample on that small category or a downsample on the larger one, and so on. The variables menu has all of the things that affect individual variables, not the whole data set. So there are a lot of standard things like various kinds of computes, conditional computes, dummy coding, and so on. One of the things that's fairly unique about BlueSky is its ability to manipulate factor levels. I was really surprised when I looked into the other tools. Generally, they had a very minimal ability to manipulate factor levels. Well, in R, the order of your factor levels, say you get a bar chart of gender and female comes before male because by default it's alphabetical order. Well, that means if you've got bar charts representing month, January, February, March, it's going to alphabetize those things. Well, you don't want that. So the ability to do all these different things like reorder by how often the category is, well, that's going to make your bar chart, all the bars go up in order or down in order, depending on which you want. You can set the order by another variable. So say I'm going to plot the means, and so I have to consider the mean of some other variable to determine the orders of the bars in the bar chart or my table of means. Missing values, it's got the usual get rid of them or replace them with a number or a simple formula, but it's also got very advanced model imputation to where you can do estimates from robust linear models, random forests, KNN estimation, expectation maximization, and so on. So way beyond what most of the other tools have at their disposal. So now analysis is, these are the kinds of analysis that don't require complex models. You'll see that there's model fitting, model tuning. We'll get to those in a minute, but these are the simple kinds of analysis. So if I want to get a summary, and by the way, most of the menus in BlueSky are in alphabetical order. And so I'm going to ask for just frequencies. And let's ask for species. I can drag it over, or I can do Control click as usual and select things and move it over. And I have a choice. I can run it, or I can say, write some R code for me. Well, first I'm going to run this, but before I do, I'm going to go and I'm going to cheat a little bit. I'm going to grab a little Markdown code. And I'm going to say, I'm going to pretend I'm writing this report for publication. And so I'm going to say, add to this output table some Markdown. And I'm going to paste in my Markdown. So Markdown, if you haven't seen it, little hash symbol says, make this a big menu. This says, make it a somewhat smaller menu and so forth. If I run this, then I see what it looks like formatted. Okay, so now let's go ahead and run this and add this to our report. So here are our frequency tables. And if I were a complete beginner and I knew nothing about Markdown or anything else, then I would probably think, well, why don't I grab this? And I'll just copy and paste it into Word. And it would work. It would go there. It would be a fully formatted table looking exactly like this with these fonts. I could then say, well, maybe I don't care about cumulative percent. I could grab that column and throw it away. And actually, BlueSky has an ability to specify, I don't ever want to see that column. So just don't ever give that to me. And that wouldn't be there in the first place. But that's getting beyond our time limit today. Okay, so let's add to this report a graph. And I'm going to do a scatter plot where I'm predicting body mass from flipper length. And let's say I want the color, I want the species to determine the color and the shape of these points. And I've got all kinds of different things, choices down here. I'm going to fit a linear model. And I've already got a title. It's remembering my title from before. Okay, that's fine. So now I'm going to say, let's run this. So here's my plot. And just to get some really nice R code out, let's make this a lot more complicated. So anytime so what's happening here is a workflow is being created, a reproducible workflow. So at any time, I can recall not just the R code, but the dialogue that created it. So here's where the beginners and the programmers can both have what they want, reproducibility at a level that they can understand. All right, so I want species out of here. Some journals charge more for color, so I'm not going to use color. I'm going to come down here under facets, and I'm going to say, I want the rows of this table, of this scatter plot to be sex, and the columns, since there are more of them, to be species. So I'm going to run that. And out comes my plot. All right, so let's get into some R code now. Here's the code that it wrote for me. So I love this language. This is the ggplot2 package by Hadley Wickham and company. And it's just fantastically flexible, but it is a bit of a challenge to learn because right up front you say, well, what are my aesthetic variables? Well, up front, nobody's got a clue as to what you're talking about. And then we've got things about geometric objects. And so it takes a couple of weeks of banging on this to really get good at it. But I can copy this code and go over to RStudio if I care to. I've already got one there. I forget which one that is. And let me just run that code. And there's the same plot. And if you look closely, you'll notice that these dots are actually kind of fuzzy. And so this is like a bitmap kind of a plot. And what BlueSky is doing instead is this whole plot is a scalable vector graphic plot. So whatever screen resolution you've got or whatever print resolution you've got, it's always going to be the highest quality. All right, so we talked about how I could have come back onto a table and just copied and pasted. So I could do that too. If I'm a total beginner, that's what they're going to think to do. I can click on this and say copy image. That'll take it to the clipboard. I could download it to a PNG file. But the best way to do it is download it to an SVG file. And if I do, then I can open my Word document and just drag the file in. Now, since it's SVG and there's a fantastic free open source SVG file editor called Inkscape, you can, like I-N-K, scape, S-C-A-P-E, you can download that for free. You can open this up and you could annotate this graph however you like before you put it into your final publication. All right, but as a more advanced user who's aware of what Markdown is, I don't want to go through these step by step because these steps of cutting and pasting, they're error-prone steps. And to get complete reproducibility, we want to avoid those if we can. So what I can do is I can just click this icon to export output, or I think actually the triple bar menu has that also, export output. And if I click on it, now I'm not sure if you can read this down here, I have three choices. The default is BlueSky Markdown, which is a Markdown file that contains dialog boxes that BlueSky is remembering for you. If I chose R Markdown, then I end up with a file that's completely compatible with any other version of R, whether it's the sad R GUI that comes with R itself or something better like RStudio. Or you can choose HTML. And if you choose that, everything's going to go into one file at once. And remember that Word can open an HTML file and interpret it. And so you'll have, boom, all at one time, the ability to open your report, complete with all of your text that you might have added to it. Okay. So, and someone asked, I should keep an eye on the chat window. Someone asked, is there a way to load Stata files in BlueSky? Yes, absolutely. It's just file open. Very, very easy. It understands, this open understands, let me close that. It understands SAS, SPSS, Stata, Excel with multiple spreadsheets. Oracle is done a slightly different way. And then there's, what's the Open SQL standard? DBMS? Oh, that's not quite right. Oh, well, anyway, there's an open database standard. There's like standardized SQL. That is actually not in this beta test version yet. So there are a few things in the production version, which was Windows only, that are not quite yet here in this cross-platform version. So this runs on the Mac and Windows identically. There's not a Linux version yet, but that should be a very easy recompile. Okay, let me check in case there are any other questions. All right, so let's see, where was I? Oh, so the next menu was distribution. And normally there would be a whole bunch of these that haven't been moved, but these are simply many different probability distributions. If you put in a value of the distribution, it gives you a probability and vice versa. So those will be moved soon. We looked at graphics. All right, so what's the difference between model fitting and model tuning? When I first saw this and I saw there's fitting, tuning, and evaluation all in a row, I thought, oh, I'm going to somehow fit this and then I'm going to see if I can tune it and make it better and then evaluate it. But no, that's not the way it works. Model fitting is a completely manual process. You have to try and get the best model you can. Model tuning is using a package in R called CARET, C-A-R-E-T, which stands for Classification and Regression Training. And it goes and tries to automatically find the best version. Oh, let's see. Someone says maybe the Mac version cannot import Stata files yet. Oh yeah, it can. You just don't have to do anything special for that. Okay, so So let's do a model, and I'm going to do regression. Really, if I do basic linear regression, this would be good for people just starting out in statistics, where I might predict body mass from a few variables here. And I can't really do much with this model. It's a simple additive model. So this is commonly the first thing someone learns when they take regression. So I'm not interested in that. I'm a power user. I want the good stuff. So I'm going to go under regression advanced. And let's say I'm going to predict body mass, and I am going to grab a whole bunch of stuff, everything but year. And so I did a click and a shift click here to get them all. And by default, you can tell I was fiddling, because by default, this plus is chosen. So by default, if I say move those variables, it also does a simple additive model. So just a plus between them all. But let's say I'm also interested in interactions. We can see that these lines are not parallel. So there's some interactions going on there. And let's say I want all possible two-way or three-way or four-way. I can get crazy here. I think I'm going to stop at two-way, because you have to have a lot of data to go further than that. And so they're still selected, and I'm going to say move those over. So now I have created one whopper of a model. And this is a situation where I doubt that I could possibly type that in R by myself without an error the first time. But here it's doing this. I can say, show me the R code, and whoops. And it pops it up, and I say, here's the LM function call that does this whole thing. But I'm not going to run that. That's a bit much. So I'm going to back off. I'm going to say, recall that. And I want to clear this. Oh, and by the way, I could have typed it. I know R models, so I could have just typed it in. Or if somebody mailed me a model, I could have just pasted the code in. All right, so I'm going to keep it simple. I want flipper length. No, I'm still on this two-way. Let me just go to plus. In fact, let me use the star. The star in R means the variables by themselves and all possible interactions among them. So I'm going to select flipper length and sex. And so when I put it in there, it's going to do all three of those two in the interaction. All right, so let's run it. So the first thing that comes out is the abstract form of what I'm asking for. So I've got my y-intercept as alpha, and beta 1 is flipper length, beta 2 is the sex when for the males. And so this little piece right here is a piece of change in y-intercept. So that would end up being added to this. Well, okay, I'm getting carried away. This isn't a class about statistics. It's just about the basics of BlueSky. So I could grab this and paste it into right into Word if I wanted to, and it would look fine. But let's do something. Let me say the rest of this is just standard statistics, so we're not going to go over that. But let's do something a little bit more complicated. So I've got this housing data set, and notice SAT or satisfaction is ordinal. So I'm going to go under regression ordinal, and I want to predict satisfaction from these three variables. And let's just run it. Oh, here we are. Oops, no, linear regression. What did I just do? Ordinal regression. Here we go. All right, I'm not sure what I did there. So now you see that ordinal regression, the thing that's being predicted is the log odds. And this is some pretty hairy stuff. So there are journals that really want you to put this in your journal article. You don't have to type it here. It's already put in for you. And so here it's put in So up here, it's alpha and beta, and you could make that beta 0 and beta 1 if you wanted to. And here we've got the formula with the values filled in. So I can't just cut and paste this directly into Word and expect to get this high quality output. This part of the formula is going to freak it out. But I can tell BlueSky to do anything in LaTeX. So I don't know if there are any LaTeX users out there. Personally, I love it. I write all my books in LaTeX, super powerful language. And so I could ask for this entire workflow to be dumped out in LaTeX, and I'm ready to publish. If you're sending to a journal in math, physics, chemistry, any of those hardcore STEM areas, the journal is going to require a LaTeX document. And getting that is not really a problem here. Okay, so let's talk about ways to, let's see if I repeated that. No, let's go back and repeat any analysis by group. So I'm going to go to data sets and say, I'm interested in grouping by a variable. Now, notice down here in the corner, it says split is turned off. And also, by the way, I've got my screen set to 150% magnification, so you can read it more easily. And that's a great tool for teaching. So split is turned off. If let's say I wanted that plot, the scatter plot that we did, where we did it by species. Well, let's say I had 50 species. I'm not going to get a single faceted plot that you can read with 50 species in it. But I can say group by, let's split. So I'm in the wrong data set. So the data sets that are the variables that are selected are based on whichever data set you've chosen. So I have the ability to flip data sets. I can have multiple sets of output, and whatever is visible, that's the input is here, the output is there. All right, so let's do split. And I'm going to split by species. So I'm going to pretend we have 50 species or something like that. All right, so now it says down here, I'm splitting by species. And so let me just run back up here and grab, what do I have? Oh, I probably don't have anything that doesn't have species in it. So let me go back to the graph, do the scatter plot. And we were predicting body mass from flipper length. And I'll run that. And so this is the species Adelaide, and that's their plot. I forgot to put the line through it. Here's the chinstrap penguins and the Gen 2 penguins. So very easy to do that kind of thing. All right. Let's see. So we were on model fitting. And we did regression. Let's do a decision tree. So we've got extreme gradient boosting, random forests, and so forth. But I'm going to choose a decision tree. And I'm going to see if I can predict the sex of the penguins from some of these length measurements, length and mass. And so here, because I chose this from model fitting, it's up to me to decide what all these parameters are. I could play around with them depending on my level of expertise. Maybe I can improve it in just a couple of tries. Now these defaults are pretty darn good defaults. So let me just go ahead and run this model. And you end up with your basic diagram to where the larger body mass penguins at this certain cut point tend to be male, and the smaller ones especially with the smaller bill length, tend to be female. So fairly simple analysis. We could do that same kind of thing under model tuning. Oh, and by the way, what did it call it? Let me recall it. So that's called tree model 1. All right, so let's go under model tuning. And I have to choose a validation method. And I'm going to choose k-fold cross-validation. And I'm going to call this tuned tree model. And I want 3 folds. So this means the data set is going to be randomly divided into 3. And the model training will be done on 2/3, then it'll be tested on 1/3. Within each set, it's going to try a whole bunch of parameter settings to optimize the model. So let's see, I'm predicting sex from these variables. And now I have a choice of what kind of model do I want. I've got lots and lots of models to choose from. Boosted trees, decision trees, k-nearest neighbors, linear regression, naive Bayes, random forests of several styles, different neural networks, support vector machines, and so on. So I'm going to keep this really simple, and I have to grit my teeth and use RPart, probably the worst algorithm here. C-tree is going to, or C50 is probably going to do a better job, and C-tree is going to would keep RPart from becoming driven into bias by having factors with too many values. But everybody, if you know one of these, you know RPart. So I'm just going to leave it at that. Tell it to run this. Okay, so it did all that work. It comes up with some accuracy, 90% classification, sensitivity, specificity, and so on. And so let's, and I forgot to turn off split by species. So I thought it took a little bit longer than usual on that. That's because I did that whole whopping analysis over and over for every species. So a very, very common mistake. So let's say group by, remove the split, and run that. Okay, so let's go back and recall. I think we could just recall any one of these. Oh, it's just one. It's just one dialog. I'll recall that dialog and just say run it again. Okay. So I got a classification table and accuracy, kappa, sensitivity, and so forth. Where is it? I'm looking for the summary. Did I choose C5? Hold on, let me go back. What did I choose there? What model? Oh, I left it on C5. I should have clicked RPart. Okay, so as we flip through this, it'll tell you, here are the things that it tried, 3 levels of CP. And then it says accuracy was used to select the optimal model using the largest value. And the final value was this. So then you could manually, if you wanted to, you could manually go back and put that into the model fitting approach. But that's okay. The model's done. So we can move on to evaluation, and I can make a prediction. So probably what I would do is I would have started out splitting this data set into training and testing and see how well it does on a completely new data set. But I didn't do that, so I'm going to pretend I did that. So I'm going to make a prediction, and I'm going to say, so which model type? If I choose a model type, it's going to simplify the, whoops. Oh, predict, that's where I was. It will simplify the list down below, but by default, it's showing all models, and I don't have that many. So I'm going to say, I want the tuned tree model. And I want to generate a confusion matrix and show the ROC table and the curve that results from that. So I'm just pretending I've got a new data set here. And so I say run. It's going to check that data set. Do you have all the variables that are needed to make that prediction? Oh, and it says, I need to specify a column name prefix. So that's because I could make multiple predictions. And so this prediction is the tuned tree, and I'll put an underscore in there. So prediction will be added on for me. So when I run that, Out comes my prediction, all my sensitivity things, which we just saw before. And here's the ROC table. So you can check if you want to balance your sensitivity to your specificity. You can do that kind of thing here. Choose what cut point do you want to deal with. I'm just going to scroll to the bottom and look at the ROC curve. Okay, so here's the curve, not bad. And sensitivity and specificity plots. Okay, so that is BlueSky in a nutshell. And so let me then go back to the slides. So these slides I think are going to be emailed to you, and the slides contain a lot of what we went over, slightly different examples. So where BlueSky is at the moment, it's easy, it's powerful. It has almost complete GUI reproducibility. So right now, if I were to open all the work that we did now and point it to a new data set, I would have to go through and go run. That's going to be an easy thing to fix. We just haven't gotten to it yet. It teaches our terminology. So right now at the University of Tennessee, you take introductory statistics, you learn JUMP. The next class, you learn R, and learning JUMP did nothing for you. It's like a total waste of time. Well, not a total waste of time. JUMP's just nice software, but it's not helping you in any of your other classes. Let me put it that way. So if someone were learning only BlueSky, they would be learning what's a factor, maybe what's an ordinal factor, what's a numeric, what's a character variable, what's a facet in a graph, what is a model, what's a model object, how are they used to predict. A lot of if you read my reviews, you'll see a lot of the other front ends to R, they're trying to make everything super easy. And so there's one dialog that does everything. There's no save a model and do something with it. You have to decide within that single data set, within that single dialog, what do you want to do? You check everything. And you say run. And I've had a number of people write me and say, gosh, Jamovi and JASP, they're way easier to do modeling. I'm like, well, you're probably teaching a class. Wait till you actually try to do some real analysis with it. Then you're going to find out, whoa, there was no model. Maybe I did a factor analysis, but I don't get any factor scores. Maybe I'm doing regression. I don't have any predictive ability. So anyway, the students are learning terminology, and then if they see the R code in their first class, then they're going to see that it's the popular tidyverse R code. So we saw ggplot code. If we were doing data wrangling, we would see maybe tidyr or broom or dplyr code, and they could start learning that. And besides BlueSky, R Commander is the other one that can save, open, and predict using model objects. That's I believe the only one. And its RMD files, R Markdown files are compatible with anything really that can run R Markdown. But you do have to get the BlueSky package, and at the moment you have to get it from GitHub. So, but it's a standard install from GitHub. The future of BlueSky, one of the first things we need to get done is get that package onto CRAN, so it's easier to reach. You don't have to understand how to use dev tools to access GitHub. A table of contents is definitely needed for scrolling through lots of output. That's on the way. The complete GUI reproducibility I mentioned, where you not only can you tell it to point it to a new data set name, but it could come up and say, hey, you don't have all the variables in here. Here's a list of variables from one data set, and here's the list from the other data set. Could you match them up? And you can say, oh yeah, it was called species over here, but the person who sent me this data, they called it genus or something like that. So you would just click on a match to get that to run. Automated update notifications. So right now, if you go to the company website, you will be asked to provide your email address, and it'll email you when there's a new version. But we really need to get that more automated. At the moment, the mixed effects linear models are fairly restricted to hierarchical linear models. Now, it does a superb job with that, but I happen to work with a team of people that does a lot of agricultural models. They don't do HLMs. They do very complex mixed effects linear models. So that's on the way. Structural equation modeling is on the way. Quality control is being added by another organization. For the social scientists, we're going to have mediator moderator through the process R package, which does a very, very good job with all the variations of that. For the medical people, we're going to have propensity scores and matching. Again, that'll be done by a very large third-party research organization. And right now, we're using the Carrot package just for kind of historical reasons. The book on Carrot by Max Kuhn is absolutely fantastic. Strongly recommend it. As soon as we think tidy models is in equivalent shape, then we'll migrate that code. Probably we'll leave the old code around someplace on a menu. And also, so what's doing the work here? What draws the BlueSky dialog box is JavaScript using the Electron toolbox. And so Python is then taking that input and it's converting it into our code. And so Python is already there. SQL would be very easy to add. So we're trying, well, eventually, this is really the most long-term of these, getting to the point to where you could create a dialog box from anything in Python as easily as you can from R. So where you can learn more, if you go to the company website under beta test download, then the version 10 user guide, be careful. You don't want to start reading the version 7.5 or something. So BlueSky, they did a lot of really massive updates, 7.1, 7.2, 7.3, 7.4, 7.5. A lot of those were very big. And then this update was a particularly huge update. And so they did what Windows did and skipped and called it 10. So make sure you've got that version. This is about, I think, 550 pages. A lot of detail, in particular, even though in the menus you can find what you're looking for most of the time, in here I warn you that, by the way, there are other ways. There are very often multiple ways to do the same thing in BlueSky. And I'll try to say, if you do it this way, it has this advantage. If you have this other circumstance, you'd be better off doing something slightly different. And I point you, there are extensive cross-references in there. So I would love to get feedback from you all. What did you think about this workshop? Please write me and let me know. What do you think about BlueSky, especially after you have a chance to poke around at it? If there are features you think it's missing, please let me know. I meet with the developers about once a week, and I'm happy to pass along any suggestions you might have. And remember, the detailed reviews of all of these front ends to R are listed on this link here. And I hope those other packages look at where BlueSky is and they see that as a throwing down the gauntlet. And I hope they step up and improve their software. So now we got plenty of time, I think, for questions. Oh, so let me read. There is a chat question. What about the spatial analysis, such as spatial regression, mapping, and so forth? So yeah, that is not there at the moment. In fact, let me point out under graphics, these maps are US county, state, and world map, very crude, very crude. So I would love for somebody to send me some R code, and even if you take a pen on a napkin and draw a dialog box and tell me what you want that dialog box to do for this spatial analysis, getting the LaTeX part that you asked about, that should be quite easy. The LaTeX part's already in there. So yeah, in fact, that's pretty much how I've designed a lot of the graphics routines. When I first started looking at BlueSky, it was all traditional R graphics, which are not very good at comparing groups. So I sent them tons of diagrams of what I thought they should look like. I sent them lots and lots of R code, and they just added it in. And same thing for data management. So these guys are, the development team is hungry, and they're a little bogged down with this beta, this massive update to this new beta version. But this is probably going to wrap up in maybe 4 weeks or so, I hope. And then they'll get on to adding new features. Okay, let's see. So can BlueSky plot odds and risk ratios? Okay, so let me bring up the previous version. So here's the production version that runs only on Windows. And you notice here it had 2 separate windows, one for the data and another one that it's still, I think I'm abusing my computer by running Zoom and a lot of other software all at the same time. So normally this pops open fairly quick. But what I'm looking for, well, I can't do it yet. Okay, I'm looking under analysis. You can see it's very different menu structure. And survival analysis, competing risk, comparing groups, one group, Kaplan-Meier estimation. These things are not yet migrated over because they were done by a large medical research group. And also, what else? Under model fitting, oh yeah, Cox proportional hazard, all of these things. One of my favorites is Cox Binary with time-dependent covariates. So this is a great example. Some people got a transplant and some other people didn't get a transplant, kidney transplant or whatever. And we have a covariate to adjust for that risk. You know, I mean, I don't think there's any other stat package I'm aware of besides raw R code that will do that. And it's there because people donated to the open source project. Okay, so I forget what plots are in there, but check my book. I don't, so many pages, I don't remember all the things I wrote. Other questions?
Bob, is there any plan, like, I didn't see it. Actually, when I was listening to, I was surprised I didn't see propensity score. Then you mentioned propensity score. So you mentioned that you work with medical doctors. So is there any way that people can upload their workflow? Like a group of medical scientists simply can create a table 1 and run some tests, and then regression analysis or survival analysis. They're just going to follow the workflow of someone else's, but
oh yeah. Yeah, absolutely. Because remember, it's R Markdown. I mean, what you can export is R Markdown that anyone that can run Markdown can run. But BlueSky to BlueSky, you would create a BlueSky Markdown file because that would contain also the dialog boxes.
I mean, if someone else sends me the Markdown file, I can run it with BlueSky, but does BlueSky provide those templates? So without asking anyone, so I can find some template and then I can try to change it myself.
So there is a feature that's so new, I haven't really used it very much. And that's the one where you look at standard BlueSky output. And the tables are just numbered, you know, say 1 through 6. And you can tell it, I don't want table 3. I want table 6 before table 5. That's just the way I always like to see things. And by the way, in table 5, column 2 is worthless to me, get rid of it. And so I can set that up. And then from then on, that template it can be applied to it. So that's so new. I'm afraid I really don't know very much about it.
Another question is, what if there is this functionality that I'm using frequently, the code? Can I add that function as a button to my own BlueSky?
Yes. I'm so glad you asked that. So when you download and install the production version, there is a thing called Dialog Builder. Nice. And it makes that process fairly easy. If you've ever done one of these things like SPSS has one, JUMP has one, and so on, It's basically what you do is you have a drawing surface and you're just dragging out a variables box, and you're dragging out a dependent variable box and an independent variable box. You just drag these all things out. And then you have to type in that, like the name of a parameter, like maybe ampersand dependent and ampersand independent list or something. Then you say, okay, the code that applies to this, I'm filling in the code with those ampersand dependent. So ampersand dependent tilde is predicted from ampersand independent list. So it was fairly easy, as easy as any of these. I've done that in SPSS, it was very similar. That feature is not yet in this new version. So what it takes at the moment is some knowledge of JavaScript, which, I'm told a good R programmer can pick up easily. I haven't done it. I've been working much more with testing and documenting. But that's the goal, is to make it to where not only can you create your own dialogue, but you can say, where do you want it to appear on the menus? What's the default location? And right now, when you install an extension, so let me go up to the website here and look at extensions. So at the moment, you can see everything that can be added and who wrote it. And whoever this major academic medical center is, they don't want to be named, so we just say that. But then there are, there's me and there's people at other universities that added all of these things. In fact, one thing I didn't mention was if you're into psychometrics, there's an entire book that uses BlueSky, and the whole book is in here on menus. Item response theory. So it's, I'm not sure SPSS even has that yet. But anyway, one of the more modern takes on psychometrics. So at the moment, you would create your dialogue, you would tie your code to it, and then you would email it to support at BlueSkyStatistics.com. It would be added here, and then people would click and they would download your extension and add it to the menus wherever they want. So it's an easy process, but nowhere near as simple as we want it to be. We want you to not be here. We want you to be here and click on this and say, show me the extensions. And then you just pick one and click install. And then it would say, do you want to put it in the default place, or do you want to pick a new menu location? And in the long run, we know what has to happen is that has to be controllable by an enterprise. We've had a number of people call up and say, this is fantastic, but I don't want my engineering team to see these social science things. It's just going to slow them down. Yeah. And I don't want my social scientists to see these engineering things because that's just going to mess them up. So the enterprise version. So at the moment, the enterprise version gets you a server version, and it gets you tech support. Is a huge thing, and it gets you listened to on what you want added. So if you've got a site license or a license of any kind from the company, of course, you have their ear, and whatever you want is going to go to the head of the queue. And I'm not somebody to talk about license fees, but I did manage license fees at the University of Tennessee for all the research software for many years. And I can tell you the price is really, really, really low compared to SPSS or, a lot of those packages that are, like one copy of JUMP that's being replaced by this major medical research unit. They're replacing 2,000 copies of JUMP that cost $15,000 a copy. Now, I know they got a discount, but come on, that's a big number. And for probably the cost of a handful of those licenses, they got a license for BlueSky. So, yeah, so it's, go ahead.
I didn't say anything about Bayesian econometrics or Bayesian stats, like Gibbs sampler, anything that is in the plan for that?
Okay, so as far as point and click goes, there was one that started it, and that's JASP. And so JASP has some Bayesian. Are you familiar with that front end to R?
Which one?
JASP.
No, I'm not.
Okay, so that is, in fact, I've got it plotted here on, where is it on the graph? Yeah, okay. So here's JASP, one of the least capable things, but it has Bayesian.
Yes, I see.
And that is, so there's a good example. If you were doing a weighted plot where if Bayesian's number one for you, well, then JASP is going to be out here somewhere. But Jamovi, since JASP is open source, Jamovi went and borrowed all their code and all their dialog boxes. And now Jamovi does everything JASP did as far as Bayesian goes. BlueSky hasn't done that, but the Jamovi people have said, come help yourself. We got it from the JASP people, so why not? And the Jamovi people, they use JavaScript and Electron also. So I would hope that that'd be an easy thing to add. Now, Bayesian, there's easy Bayesian and there's like super flexible Bayesian. I don't know whether how far JASP goes with that, but it should be easy to copy that.
Thank you. There are some other questions. I don't want to monopolize it.
Oh, yeah. Okay, so do we have any security issues to use R in general or BlueSky in particular because those issues prevent its use in a company? So, that's a good question. I think there were a lot of companies back in 2005 when I started using R heavily that went, well, what is this thing? I actually went and taught a workshop to like 40 people. We went in the day before, we installed it on like 40 machines. And the minute the workshop was done, it was like a 2-day workshop on R. The minute it was done, I had to help these people delete R off of all these machines. I'm like, one of the craziest things. But lately, since the FDA accepts, analysis done in R, and in fact, some FDA people have said, well, if you send us SAS code, we're going to double check it in R. If you send us R code, maybe we'll double check it in SAS. I don't think that there are too many places that have an issue with that, but there is the question of open source license versus commercial license. And so the open source license is, here it is, you're on your own. You can, if you buy tech support, you get a commercial license. And now you've got, you can pick up the phone and contact somebody, get something, if something's broken, get it fixed really quickly. So I think that's really about the only security issue that I can think of. Does that cover it? Could be virus. Yeah, sorry, no help there. I don't know of any viruses that affect BlueSky or our studio or the plain old R GUI more than anything else. I am a huge fan. You can probably see. I've been running Windows 11 in beta test for months because I take security very seriously. And this thing is locked down tight with hardware. They even warn you that if you're running games, some games you give up 50% performance, I don't care. I want hardware security that prevents rootkits from coming in and infecting my machine. So yeah, I'm very, very concerned with that. So I appreciate that question.
And there is one question. I also have a related question. Can we run external Python code? Can we call external Python code some deep learning models written in PyTorch, for example?
No, not yet. That is where we're headed, because when you install BlueSky, what you get is a copy of R, even if you already had it installed. You get, I think, 320 R packages, even if you already have them. You get a copy of Python and some of the Electron tools. And the reason we waste a little bit of disk space like that is that R has a big problem with package management. So anybody that has used R for any length of time has had a program that worked great 6 months ago. I remember my boss came flying in one day. It's like, I've got this meeting. They want an updated report. I got to have it now. Said, no problem. I popped it open, aimed it at the new file and said, run.
No.
Got some error messages out of it.
It happened. Yeah.
Because they had improved
Yeah.
the package. So since you're getting BlueSky, if you're getting the entire bundle of things. So if you know this package ran 6 months ago and you still have BlueSky from 6 months ago, or you go to the website and download the one from 6 months ago, it will run because all the packages are there. Now, there are all at least 3 different approaches to package management that have various pluses and minuses. Compared to this, they're all complex. This is like dirt simple. And, I really love not having to worry about that issue anymore. Okay, let me back up and see if there are other chat questions I missed. If someone had tried to install or load a Stata file with the current beta, just wait like a week. You'll get an email about that. And the version you can tell, well, you can't see it, but the version I'm using does. I have tested that. We added that last week. We thought it was there actually. Okay, looks like that's all the questions in chat. But I am happy to hang around here for as long as anyone wants to keep asking questions. Thanks very much for attending.
Thank you very much. Okay.
Thanks for the feedback. I appreciate that. So how many people showed up in the end?
I think we had 24 participants today.
Okay. Yeah, whoever signs up, I always figure out about half.
Yeah.
And not running into last minute delays.
But we have the recordings, and then some people may watch it later. So
yeah, great.
Okay then. All right then. I think there are no other questions today from anyone.
Okay.
Thank you so much. Thank you so much for the talk. I really enjoyed.
Thanks for the opportunity. This is like a lifelong obsession with me. I have waited a long time for this moment to where I can be happy working. People can bring me their workflow in a point and click, and I'm happy to see it.
Did you use BlueSky when you're teaching stat or say machine learning in a class?
Oh yeah. I've taught. So companies hire me to mostly go and teach. I have a 2-day workshop on just R, 1 day on data management, 1 day on machine learning, and it's all code. And I'll usually say, oh, by the way, like at the end of the machine learning, I'll say, by the way, did you know that the entire 7-hour day could be replicated with a few clicks over here?
That would be awesome.
Sometimes they're not thrilled to hear that. But I am teaching tidy models now. I switched about 2 years ago from tidy models to from Caret to tidy models. And so, yeah, I'll be happy when BlueSky makes that transition. But I understand they want something to be rock solid and thoroughly tested before they make that step.
Okay. Thank you so much. For giving this talk to us, and then hope to see you again.
Okay, great. Thanks.
Thank you. Bye.
Bye-bye.